Now today we're going to be working again in Microsoft Visual C++ 2010 Express, looking at different ways to implement a simple function, which in this case is finding the maximum value in an array of integers. Now we're going to compare the C version of a program to 3 different versions of the assembly language program, and we're also going to introduce some new instructions and implement them in the programs. The first instruction is CMP, which stands for compare. Compare will compare the value 1 to value 2 and set the flags accordingly. Actually, behind the scenes is actually subtracting value 2 from value 1 and setting the flags, but it doesn't actually make any changes to either of these operands. It only changes the flags. And again, we just use that to compare values to each other. Another instruction is the loop nonzero, which is LOOPNZ. Loop will jump to a particular label. Well, actually, the first thing that it does is it decrements the ECX register by 1, and then if ECX is not equal to 0, greater than 0, then it will jump to the label specified. And this is very useful for doing looping structures in assembly language. Now, another instruction is the SHL, which stands for shift left. And what shift left does is it takes this destination register and shifts the bits in it over to the left by the number in this count value. And of course, and this count value can only be in the example we're going to be doing today, these are just going to be constants. But the effect of shifting left is the same thing as multiplying by 2. So if you set this this count value to 1, it would actually be the same effect as multiplying by 2. And I can show you how that works. Go into Calculator, and if you didn't notice this before, in the Windows Calculator, over here you can actually modify the base in which you're operating. So this will allow us to switch between hex, decimal, octal, and binary. Today we're only going to be looking at decimal and binary values, but let's take initially a decimal value of 5. We convert that to binary, you get 101. Now, shifting left I'll demonstrate, is exactly the same thing as multiplying by 2. If we take 5 and multiply it by 2, we end up with a value, obviously, of 10. But in binary, that's 1010. So this has been shifted left. And of course, shifting left means the same thing as adding a 0 on the right-hand side. So when we do that again, 10 times 2 is 20. The binary value of that is 10100. So we've added yet another 0, and so this is the same thing as multiplying by 2. Now, the same effect is if shifting right is the exact opposite, or the inverse, I should say. If you shift over to the right, you are dividing by 2. So divide divide by 2, you get the value 10. You'll see that you have 1010. We take that, divide that by 2 again, you get 5, which is 101. So shifting right means you're taking a bit off the right-hand side, and so that's basically doing an integer divide. Now, if I divide this again, take 5. Now, if we do an integer divide of 5, which I just put in 10 because in binary, the decimal value 2 is represented by 10 in binary. If I do that divide, you end up with 10, which is 2. So basically we've just shifted over one bit. In this case it erased the rightmost bit. So the integer, if you do an integer divide of 5 by, if you take 5 divided by 2, there's no decimal point in integer divide, so 5 divided by 2 ends up being 2. We'll go back to the program now. The program is, the whole purpose of this program is to go into this, take this int val. We have an array of integers, 4 integers in this case, 1, 4, -1, and 3, and this array, we're going to go through that and find the highest or maximum value in that array. Now this character format is merely used to print out the result after we figure out the maximum value. This int I is used in the C program. The I is the counter value that is going to step us through each of the 4 values in the array. This max val is where we're going to store the maximum value. Now the first thing we need to do in this program, and I will start it up. First thing we need to do is initialize the value of max val, and either we set that, since we're trying to find the maximum value, either we set that to a very small negative number, or we just set it to any value in the array we're trying to do the maximum. We're finding maximum value. So in this case, we'll take the first value, which is 1. We'll assign max val equal to that. So max val is now equal to 1. I've got the watch window set up over here. We're watching I, max val, and int val I, which is the current value indexed by the I counter value. So now we go into this loop. First time through the loop, the I gets set to 3, which it is, and then the next step is to do the comparison between the max val value, which is initialized to 1, and what's currently in the array. Now, as you can see, int val I is equal to 3, max val is equal to 1, so that turns out to be false. So we come down here to the else, and max val is going to get overwritten by that value of 3. So now max val is now equal to 3. So we'll go through the loop again. I gets decremented down to 2. We do the comparison again, except this time int val is equal to -1, and that's how we represent. That's how these 8 F's is how a -1 is represented in the computer for a 32-bit value. So it turns out in that case, -1 is obviously not greater than the max val, so there's going to be no change to the maximum value. But in this case, int val, this time when we go through, int val is going to be equal to 4. That's greater than a max value of 3, and so now the max value is now 4. And we're going to go through this one last time with I equal to 0. We're pointing to the first value in the array now, which is 1. And as you can see, as we went through, that value is not larger than the max val. So our final value, max val, is equal to 4. And as I showed you before, that's the format we're going to use to print that out. So if we step over that, you see that the program is going to print out a max equals 4, which is correct. The maximum value in that array is 4. So now we're going to do the same thing in assembly language. Obviously, it's going to be a little bit different. The first thing we need to do is initialize a pointer to the int val integer array. And that's what this does. Load effective address of int val into the ESI register. And that's what that does. If you come down here, copy that value of ESI, and put it in the memory window, you can see over here that here's our 1, 4, -1, and 3, which is the integer array. So now the next step is we need to set up, figure out where we're going to put our maximum value. And again, just like in this C program, we had a place to keep the maximum value. For the assembly language program, we're going to use EAX as that storage area, and we're initializing EAX to that first value of the array, which is 1, which makes sense. The first value is 1. We're setting EAX equal to 1. Now we also, just like the C program, has a counter value. In this case, we're going to use ECX as a counter value. We're going to loop through 4 times, so we're going to set that to 4 because there's 4 items in the array. And now we're going to do our comparison between the max val, or with EAX storage area, and the value currently pointed to by the ESI register. Now, and again, that value is 1. EAX has been initialized to 1, and so we're comparing 1 and 1. Is 1 greater than or equal to 1? Yes. So we're going to do, so this jump greater than or equal to, it is equal to it, so it's going to jump to the label 2, and which effectively skips this instruction. There's no point in copying the there's no point in changing the EAX register because those values are equivalent. So now we need to skip to the next item in the array. So we have to change our ESI pointer to the next item in the array. And since these are integers, we need to increment that ESI register by 4. So ESI is going to be, here's the ESI register, and if you can add in hexadecimal, you see that is correct. We just added 4 to that, and if I copy that over here, you'll see that we're now pointing to the value 4, which is the next item in the array. So now we're going to decrement our counter value, which is the loop counter value, which is ECX, and that's now set to 3. And jump non-zero. If ECX was 0, then we would have fallen through, but it's not 0, so now we jump back up to label 1. Again, we do another comparison. EAX gets compared to the value in the ESI register, which is 4. So EAX is set to 1. ESI is 4. It's not greater than or equal to. So EAX is less than, EAX value 1 is less than the value pointed to by ESI, which is 4. So now we're gonna overwrite what's in the EAX register with that value, which is 4. We again increment in this line, increment the ESI register to point to the next item in the array, which is 22FAC4. Change this to C4, and now we're pointing to that item, which is -1. ECX is 2. It is not 0. So we're going to jump and conditional branch back up to the comparison. Do yet another comparison. We're comparing EAX value of 4 to the pointer, to what's pointed to by the ESI pointer, which is -1. That's definitely going to be less than, or I should say the EAX register is greater than, so we're not we're going to jump and we're not going to save that value. We increment the ESI pointer. We now decrement our ECX, which is our loop counter. We jump back up. This is the last time through. We do a comparison 4 to the ESI register, which is now ESI is now this value, which is the same as up here. We're pointing to the value of 3. We're not going to save that because it's not greater than our current value of in the EAX register. We increment the array pointer here. We decrement ECX, which is our loop counter. Now, ECX is now equal to 0, so jump non-zero is not going to jump. So that means we're done, and we're just going to save we're going to save this value of EAX, which is the max val, and we'll replace that in the max val in memory, and then we print it out. So as you can see, we've got our assembly language version of this program worked exactly the same, and but now we're going to do a slightly different version of that. In this case, we're going to introduce the loop non-zero. Loop non-zero, as we said, subtracts 1 from ECX. So and then it does a jump non-zero. So basically, it replaces these two lines. So this line replaces these two lines and makes it a little bit shorter and hopefully a little bit easier to understand. So I'm just going to skip through this. And as you can see from the output window, that produced the exact same result, which is good. And now we're going to do this a different way. The C program up above uses indexing into the array, and we're going to do that even though it may make things seem a little bit more complicated. But we'll start here in the beginning. Again, EAX is going to be where we store our max value. We initialize that by copying in the first value of the array. So ECX is now 1. We're going to move 4 into the ECX register because that's going to be our loop counter. And because we have to loop through that array 4 times. Now we're using ECX as a loop counter because this loop non-zero uses that register to do its looping. Now, since we want to index into an integer array, we have to multiply the ECX by 4. The way we do that is by shifting ECX left twice. So ECX currently here is 4. When we go past that shift left, it's now going to equal 10 hexadecimal. Hexadecimal 10 is equal to 16 decimal. So you can see, so 4 shifted once is 8. 4 shifted twice would be 16. So that makes sense. Now we're going to in this comparison to our max val, which is EAX, is going to be compared to a pointer to int val plus ECX. So we're taking int val plus 16 minus 4, and the reason we had to subtract off 4 is because we're indexing off of this ECX register, which again, loop non-zero stops looping through that when it becomes when it hits 0. So we need to subtract off 4 so that we're pointing to the right point in the array, just like we did in the C program. So if we've got int val, which is 22FABC plus 16, that's actually going to point, at that point we're going to be pointing to the end of the array. So that value is actually 22FAC8. The last value in the array, and that's what this is pointing to. So we're going to compare the value of 3 to what's in the EAX register, which is 1, and so that is so EAX is greater than, or I should say is actually less than, EAX is less than that, the EAX value of 1 is less than the value of 3 pointed to by this value. So we're not going to jump. We're going to copy that value of 3 into the EAX. So just like in the C program, we're starting from the back of the array and checking and moving through it all towards the front. So now, again, we multiplied ECX by 4. Now we need to undo that so that the loop non-zero can loop through it. And so now ECX is set back to 4. You can see the loop non-zero will just subtracted off 1, so now it's 3. And it also, since ECX was non-zero, it jumped back up to the label 5. And again, we're going to shift left ECX again because we're going to use it as to help us index into that array. Now I also should have mentioned that this instruction is called indexed addressing mode, and you can use multiple registers to index into arrays, and you can have multiple registers for indexing, which can be useful for like 3-dimensional arrays, 2 and 3-dimensional arrays. So now again, we're doing a comparison here. EAX is going to be compared to the next value in the array, which go down 4 here. That's going to be the -1. So that's not going to change anything. We loop through here again. We've now subtracted off 4 because ECX is down. ECX is now set to 8. So it's the pointer to the array plus 8, which is 2 integers over. So now we're looking at the value 4. So EAX is 3. Our max val substitute is 3, and that is going to be less than the value in here, int val plus ECX minus 4. So we're going to move that value of 4 into EAX, which is true. We're going to shift right ECX so that, again, the loop non-zero function will work. It's now 1. We're going to go through our last iteration through here. This guy is going to be now pointing to a value of 1. And that is not greater than our EAX register value. So we're going to end up here. Loop non-zero has just decremented the ECX down to 0, and because it is 0 and not non-zero. If it was non-zero, it would go back to the label 5, but the 0 flag is 0. It's non-zero, so it is 0, so it is going to skip through here. And the next statement is to copy EAX into into maxval, so we can print it out. And as you can see, all 3 of our programs have produced the same result, which is good. But one other thing I wanted to show you, though, is that here we have this loop counter. We had to manually figure out how many items were in this array. Now, another way to do that is to use the length instruction. Now and then we put in int val. So that's going to give us the length of this array. Now, which in this case is 4. And that saves you the trouble of having to manually figure out counting how many items in the array. It just if you were to add something to that array, it would automatically tell you. It would automatically put in 4 for this. We also got another function which is type. Type looks at, this is type int val. Again, because we're incrementing this pointer by 4, we're only doing that because it's an integer value, which is the size of 4 bytes. So if you don't want to have to know the fact that an integer is 4 bytes, you can use this type to add, in this case, to increment the pointer for us. So now I'm going to stop this and spin it again. It's well, I will do this.